Welcome to the engineering mechanics class. So here we will study different type of friction, okay, along with the relevant terms in using friction. So friction, as all we know, it is one type of retarding motion which opposes the forces when we are acting. It directly acts in the opposite direction when we are applying the forces. So in friction, it can be two types, mainly static and friction, static friction and kinetic friction. Also, the fluid friction is also there. So there are different types of friction depending upon this one. So the sources of dry friction generally we consider. So what are different type of asperities which are present in the contacting surfaces? Then the interaction considering in the atomic level, and the tribology studies for the force of friction. That means what the conditions which for are the sources of frictions are those are lubrication, wear and tear, etc. Now, if we see the coefficient of friction relation, there are two reasons in this figure. If you see, this is the force of friction acting this y direction and application of the friction force in the x directions. So you see there are two regions in this diagram. One is you will be static regions where the force of friction is directly proportional to the applied force. So the coefficient of friction in this region, it is mu s, that is coefficient of static friction. So up to this point the force of friction will be directly proportional. That means whatever the force applied, the friction force will be up to that much amount. Now from this part, if you see, when we increase the forces, then at that time the frictional forces will start reducing. Okay, so this part it is called the kinetic region. So here what happened here, the force of friction, that means the net force will be your the applied force minus the frictional force. If you subtract this frictional force from the net force, then we will get the F application, applied force. So that's why where F net force will be F applied minus frictional force. So this friction force here it is given by in the kinetic region mu k into n, where mu is the coefficient of kinetic friction, n is the normal force. So this is shown in this diagram also. This F applied equal to F net plus small f. That means F net small equal to F applied minus small f. So at the impending motion means when the body is just about to slide or move, then at that point your force of friction will be becomes equal to your mu n, where n is the normal force and mu is the coefficient of friction. So this is the maximum force for a given n. That means now this force is the maximum force, the frictional force. So mu is the coefficient of friction. For the impending motion, we have mu equal to your mu motion. That means for relative motion, mu becomes equal to mu k. And from this relation, we can find out your mu k value is always will be less than the mu s. Why mu s? Because if you from this relation, if you put this value of mu k here, so it will be f net minus fk divided by n. But here in this case you see mu s, it will be directly divided by fs max divided by n. So there is, due to this reason, your coefficient of static friction is always greater than the coefficient of kinetic friction, because in the coefficient of static friction the body will be at the rest. That means the maximum force will be, maximum frictional force will be equal to the applied forces. But here in this case the frictional forces is overcome by the applied forces. Due to this your kinetic friction coefficient is less than kinetic static friction coefficient. These are some different values of coefficient of friction in dry surfaces, like metal on metal, metal on wood, metal on stone, metal on leather, wood on wood, wood on leather, stone on stone, earth on earth, rubber on concrete. So these are the some typical values. Has been measured experimentally. These values are found in this range. Highest, if you see from this one, rubber and concrete, this value is 0.6 to 0.9. But art on art also is there. The value is 0.2 to 1. But average value of this one is more, rubber and concrete. So now the maximum static friction force, it is given by Fm equal to mu s in n, and the kinetic friction force your Fk equal to your mu k n. So both maximum static friction force and kinetic friction force, these are proportional to the normal force, and it depends on the type and the condition of the contact surfaces. But one important thing, that though it depends on the type and condition of the contact surfaces, but it does not depend on the area, contact area. So for small contact area also may be same, for large contact area also maybe the coefficient of that means the friction force may be same. So these are the some properties, or you can say some characteristic of the friction force, both static and kinetic friction. Now if you see this figure, here in this case, a rigid body is contact with a horizontal field. There are four conditions may arise from these figures. In the first case, when your frictional force is 0, only this normal force will be balancing by your the weight of this body and this P. Okay, P means this is the applied force. In this case, second case, here the frictional force is acting, but the body is not moving. Here in this case, what happened? Why it is this? Is because the applied force is less than the frictional force. Now in this third case, if you see frictional forces is acting, but here the body is impending. That means body just start to slide through this plane. So here Px equal to your will be your Fm. It means applied force becomes equal to the friction force. Now if you consider this one also, what happened? The body is moving. The body is moving. That means it crosses the frictional forces. That's why the applied force becomes greater than the frictional forces. Here now we'll study this one. What is the angle of friction? So angle of friction, if you see in these four figures, if you see in the first case there will be no friction. In the second case, what happened? Motion, there is friction is there, but it is balanced by the applied force. So that means here is no motion is there. This one, if you see this one, the angle of this resultant when the applied force is there with the normal. Okay, in this case what happen, your this angle will be less than their static friction angle. Okay, but when if you consider this figure, this angle becomes equal to this friction angle. Okay, or you can call static friction angle. That means it about to move. That means it about to start at this position. This angle is static friction angle becomes equal to this angle. That means the position at which a body just begins to slide through another body, that angle it is called, the angles of friction. So if you see this one, this R is making an angle of phi. That means for this angle, this angle, that is the maximum. That means at that point, the angle through which it makes the resultant makes an angle with the normal reaction. At that time, if the body just begins to fly, that is called the angles of frictions. So now what happened here in this region, your Fk, number 4 case, Fk means coefficient of is your kinetic friction force. It is less than Px. So that means this angle becomes your friction angle, but kinetic friction angle, because in this region the whatever the friction forces is acting, that is the kinetic friction. So From this value you can find out in this can when motion is impending, then phi becomes equal to your coefficient of friction, and in this case when the body in movement, then phi k, that means that it becomes equal to your coefficient of kinetic friction. So similarly, this value when we can find out when a block of weight resting on a board with different inclination angle theta, then from this here, if you see this one, frictional angle will be your, it means force of friction, that will becomes equal to your W sin theta, and the normal force become equal to your W cos theta, because this W is making an angle of theta with this normal. That's why n equal to W cos theta, f equal to W sin theta. Similarly, here also you see this angle phi s, that means at the motion impending, that means at that position when the body, the frictional angle with this body with the normal at which the body just begins to slide, that is called the angle of repose at the time of the body just begins to slide. So if you resolve the components, we will get this normal component equal to W cos theta, Fm equal to your W sin theta. At this position, theta becomes equal to phi s. That means this angle friction angle will be becomes equal to angle of static friction. Similarly, in this case, the fourth case, we will see this one. Here the body will be in motion. Now here this phi k becomes equal to your theta equal to becomes phi k. So if you resolve the component in normal direction and in horizontal direction, so fk becomes less than your W sin theta, and n equal to your W cos theta. N will be balanced by the cos component of W, this normal direction. So this one, if you see in this figure, if you see this one W, this W P is acting at an angle. So here what happened? The all applied forces we know, coefficient of static friction also know. So now we have to find out whether the body will be in remain at a slide. So this one is Fm, that means applied forces, the friction forces is mu s n, that means motion is impending. Now we have to find out the what will be the value of the coefficient of friction. Now your this one also we know the coefficient of static friction in these cases. So the motion is impending in this, that means body will slide in this direction. So the friction force is acting in this direction. So we have to find out the magnitude of the direction of one of the applied forces. This is the applied forces. Here also this is the applied forces. Likewise, we can find out the values of the different coefficient of friction. Here in this case, here also you can find. Then you can find also the applied force depending on the how the bodies are acting on this plane.